Okay, so in this problem we're going to solve for n, the number of periods in a compound interest problem using a trial and improve approach. So in this question we're asked how long does it take for an investment of $12,000 to gain at least $2,000 of interest in a savings account that compounds quarterly at a rate of 3.6% per annum. Okay, so writing down the compound interest formula and then writing what we know. Okay, so in this problem we know the starting amount, the principal, which is $12,000. We know that our final amount in the account we want to be at least $14,000. The interest rate per period is 3.6%, but it's quarterly, so we divide by 4, and we're trying to solve for n here. So let's substitute in what we know. Okay, so that gives us this expression here, and what we're after is the values of n that makes this equation true. We don't have the mathematical skills yet to solve for n directly. You'll learn them in your extended maths class. So what we're going to do is use a trial and error approach. But a good idea here would be to figure out what this value here is that makes it a little bit easier. And here we're quite fortunate in that this calculation, 1 plus 0.036 on 4, equals an exact figure of 1.009, indicating a percentage increase of 0.9% each term. Okay, so what we're going to do is guess values of n, and they're not going to be too large in a question or a test, to try and find the condition of when does this equal 14,000. And the question, I don't really need it exactly equal to, I just need this to be bigger. So to start here, let's just confirm that 1 plus 0.036 on 4 is the answer I got. So on the calculator, 1 plus 0.036 divided by 4 equals, and let's convert that into a decimal, and we see the figure that I just showed you. So the idea here is that each quarter, that's the factor at which the $12,000 grows. So after one quarter, we can figure out the amount in the account by going 12,000 times by the answer that was just in my calculator equals. Okay, so that's clearly not enough. It's not $14,000 yet after one quarter. So let's times that by 1.009 again. And it's quite nice here, if I've got it in terms of answer times, I can hit equals. So that's after 2 quarters, and that's not enough yet, because I'm after the first number that's more than 14,000. So what I'm going to do is keep on pressing equals and keep track of which quarter I've got. So this is quarter number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is not enough, 17 is not enough. After 18 quarters, we're in the position where we've earned more than $2,000 interest. Okay, so using the calculator, we just found that after 18 quarters, we reached the required interest of $2,000. So I've repeated that calculation here. The final amount in the account, investing $12,000. Here's our 3.6% per annum adjusted quarterly over 18 quarters, and we get a final amount of $14,110. But what I'd like to see in your response to this question is that this is the first time that we reach the required amount. So I want to see another calculation here of 17 quarters, because if you do that, you see it's not quite enough. So the minimum amount of time to earn $2,000 in interest is 18 quarters, and it's good to communicate the final figure in years, so that's 4.5 years.